Hey everybody, in this video I'm going to teach you everything you need to know to get started working with Matplotlib. So I encourage you to sit back, relax, and enjoy the show. Matplotlib is a Python library for creating charts and graphs. You can take plain numbers and turn them into visuals you can actually understand. With just a couple lines of code, you can make your first graph. Boom! Instant line graph. You can create line charts, bar charts, scatter plots, histograms, and my favorite, pie charts. Because I like pie. You can customize the appearance of what your charts look like too. Here I went a little crazy with the customization, but I think you get the idea. What I would recommend before starting the series, be familiar with all Python subjects up to dictionaries. Knowing NumPy and Pandas are helpful, but not necessary for the series. I do have some free courses on YouTube to catch you up to speed if you're interested. Anyways, let's begin. Oh yeah, let's do this. To start working with Matplotlib, we have to be sure that we have the library installed. One easy way to check that, at the top of your IDE, if you were to import Matplotlib, if it's underlined red, you can hover your cursor over it and install the package by clicking this link. Now, if this pop-up doesn't appear, if you're using PyCharm, you can open up a terminal. Alt F12 is the shortcut. Then use pip to install Matplotlib. Pip install Matplotlib. Enter. Give it a moment to install, and that's all you gotta do. We can close out of this terminal. And that red underline should go away. To check the current version, within a print statement, we will print access the library of matplotlib dot dunder, meaning double underscore, version. Dunder again. The current version of Matplotlib that I'm using is 3.10.6. We can delete this print statement. There's a module called pyplot. It's found within the library of Matplotlib. It provides a user-friendly interface for plotting. We're going to import that module by following matplotlib with .pyplot. So altogether, import matplotlib.pyplot. That's a tongue twister. Just so we don't have to type this long name every time, we're going to give it an alias or nickname as PLT for short. So in order to access, here we go, matplotlib.pyplot, we're just going to give it a nickname of PLT. Here's how we can create a basic plot. We'll need a set of x and y coordinates. We'll start with a basic Python list for the x coordinates. We'll say x equals a Python list. Here you can type in some numbers. I'm going to type in some years. 2023, 2024, 2025, and 2026. And then for the y coordinates, this will be a separate Python list. Make up some numbers. In this scenario, let's pretend that we have different class sizes each year. Starting with 2023, there's a class size of 15 students. Then for 2024, we have 25 students, then 30, and 20. Feel free to pick different numbers if you would like. We have a list of x coordinates and a list of y coordinates. Each set of these elements is a pair of x and y coordinates. We have to be sure that they match. Now, to create a basic plot, we're going to access plt dot call the plot function, and then pass in our coordinates, x, y. The first argument is for the points on the x-axis. The second argument is for the coordinates on the y-axis. Now, if I were to run this, nothing displays. You also need to call the show function of your plot. Here's how. When we would like to show our plot, we will access plt, call the show function, in order to show our plot. Now, I'm using PyCharm. My plot appears on the right-hand side in a separate window, called Plots. Here's my x-axis with all of my years, but we'll have to do some customization in a future topic. Then here are all the y coordinates. For 2023, we have 15. 2024 is 25. 2025 is 30. And 2026 is 20. And you can change these coordinates too. I don't know, I'll set 30 to instead be 1,000. Let's see what this looks like. And we get a different plot. But I'll change that back. You can also close out of past versions of plots by hitting this X button next to each. Now for the plot function, if you only pass on a single parameter, this argument would be for points on the y-axis. And here's what that would look like. The default behavior for plot is to start at 0 and place a point at each increment of 1. 1, 2, 3. But each of these ticks, they increment by 0.5 each. The points on the x-axis will be provided to you. But we'll pass in both x and y. Now, if you're familiar with NumPy, we could instead use NumPy arrays because they're faster than Python lists. To set that up, we will import NumPy as NP for short. We'll assign x to be a NumPy array, np.array function, and then pass in your Python list. Then do the same thing with y, np.array, pass in your Python list. And that's all you have to do. NumPy arrays are faster than Python lists, and give you more functionality. Your homework is in the comments section. Either post 2 lists or 2 NumPy arrays. Try and think of something creative if you can. Alright everybody, and that is an introduction to creating basic plots in Matplotlib. In this video, I'm going to show you how we can start customizing our plots. More specifically, we'll be customizing the lines and markers. Here's how. Within our plot function, we can pass one of a few keyword arguments, one of which is marker. Marker equals a given character. Depending on the character that you set for marker, your marker will be one of a few symbols. For example, if your marker is set to be a period, a point, each set of coordinates has a point, although it's a little hard to see. I'll try and zoom in. You can see that each set of coordinates has a point. Another is circle, that would be an O. Triangle down is a V. For a star, you can use an asterisk. These are a few markers you can use, but not all of them. If you read the documentation, there's a fairly extensive list. For our project for the marker, we'll set it to be a dot, a period. But then you can change the marker size if this is too small. That will be a separate keyword argument. For the keyword argument of marker size, pick a size. Here's what 10 looks like. Here's 20, 30. What's 1,000 look like? I'm curious. No, go back. We'll set it to be 30. For the marker size, it can be abbreviated to MS. MS meaning marker size. But for teaching purposes, I'll keep this as marker size, just because it's easier to read and understand. Here's how to change the marker colors. This is a separate keyword argument. Marker face color, and here you can pick a color. You can select the name of a color, you can use RGB values, hexadecimal values, or HSL values. Let's start with something simple like the name of a color, such as cyan. The markers are now this color, cyan. But for better customization, I recommend looking up a color picker. So here's a color picker that we can use. I would like a very specific shade of blue. Something like... that's pretty good. I'll just select this hexadecimal value. We're going to paste that hexadecimal value and rerun this program. And now we have a very specific shade of blue for the marker face color. For this keyword, you can also shorten this to MFC. It's shorter, but not as readable for a beginner. I'll keep it as is, marker face color. Then for the edges, you can use marker, edge, color. I'll set it to be the same color, or you could pick a different color if you would like. We'll keep it the same. Now the edges of each marker are the same color as the face. The abbreviated version of this word is MEC, in case you see it. Now we'll start working with the lines. You can select a line style. The default is solid. Let's use a dashed line. Here's what it looks like. For the line, it's now dashed. Or we could do dotted, dotted. We have a dotted line now. Or dash dot, dash dot. It's a combination of dashes and dots. Or for no line, if you just want the points, the markers, you can set this to be none. Then we have no line. But let's set it to be solid. Solid. Here's how you can change the line width, because right now it's fairly skinny. We will pass in a keyword argument of line width. Normally it's 1, but here's what 2 looks like. I'll set this to be 3, 4, and I don't know, what's 10 look like? That's a little too much. Let's set it to be 4. Yeah, that's pretty decent. Here's how to change the line color. Set the color to be, then pick a color. I'll use that color picker again. Let's see, I'll select something kind of dark blue, like that. Copy and paste the color value. And here's what we got. Our line color is now a very specific shade. Now, let's say we have more than one line to customize. I'm going to create another NumPy array. We'll rename y as y1, plot x and y1, then we will also have y2. And I'll just do some copying and pasting. y2 will have some different values. Make up some values. I'll say, I don't know, 17, 23, 38, and I don't know, 5. Again, your values don't have to be the same as mine. Feel free to pick some different numbers. We're plotting x and y1, but we'll also plot x and y2, that set of coordinates. Access PLT, call the plot function, pass in x and y2. So now we have 2 lines, but our second line doesn't have the same customizations as our first line. Here's one option, although I don't recommend it. You could copy and paste all of these keyword arguments and pass them in. This would work, although here's a much better option. You could instead create a dictionary with all of these keyword arguments. And then when we plot a line, we can just unpack our dictionary. Here's how we can do that. Let's create a dictionary which we'll name line_style. This will equal call the dictionary function to create a dictionary. We'll cut all of these keyword arguments and then place them within this dictionary function. Now we could just pass in this dictionary when we plot a line. We just have to unpack it using double asterisks. Unpack the line style dictionary. Then it's as if we're passing in all of these individual keyword arguments. We'll do this for the second line as well. Unpack our line style dictionary. And it's the same. Let's create a third line. We'll name this line y3. This will be another NumPy array. Make up some values. 13, then 15, 20, and 30. Then we'll have to plot this line. Access PLT, call the plot function, pass in our new coordinates, x and y3. Then we will unpack our dictionary of line style. Then we should have a third line, which we do. All of these lines are the same color. That's because with our dictionary of line style, we've set all the colors to be the same. But you could pass in an individual color. Think of this as the default color for all lines if we use the line style dictionary. Another option is that we can cut this keyword attribute of color and then pass that as a separate keyword argument, as well as the line style dictionary after unpacking it. So let's pass in a color, then pick a color. I'll keep the first line to be blue. For the second line, I'll pick a different color. Let's go with something green. That's good. We'll pass in a different color for the second line. Then for the third line, I'll pass in a color that's red. That's good. And now each of our lines has a different color. Alright everybody, so that is some basic plot customization. In the next video, we'll discuss labels. To help increase engagement with this video, comment down below what your favorite food is. And well everybody, that is an introduction to plot customization using Matplotlib. Alright everybody, in this next section, we're going to customize various labels, our title, and the ticks of our chart. Here's how we can customize those. In this demonstration, I have various class sizes year by year, the years 2023 through 2026. These are all NumPy arrays, but you can use Python lists too. To set a title, we're going to access PLT, call the title function, and then we can pass in a title as a string. We'll set the title to be class size. Then we will run this and we should have a title. Class size, although it's kinda small and hard to read. Here's how we can customize it further. We can pass in some keyword arguments, one of which is font size to change the font size. I'll set that to be 20. Here's the new title. You can also change the font family, and it's just family. I'll pick Arial. That's a professional looking font. You can set the font weight to be bold. Font weight equals the word bold. Let me make the title a little bit bigger. Let's say 25. That's better. Let's also set a color for our title. Color equals, here you can pick the name of a color, you can use RGB values, you can use hexadecimal values. I'll pick something kind of dark blue, like that. I'll copy the hex value, and then set the keyword argument of color to be that hexadecimal value. And now our title should be a specific shade of blue. Now we'll set a label for the x-axis. We will access PLT, call the function of x label. We'll set the label to be year. And we should have a label on the x-axis for year, although it's kind of small. We'll change the font size. We'll copy the font size from our title, but set it to be 20. Here's the new font size. Let's change the font family. I'll pick Arial again. I'll set the font weight to be bold. And then I'll pick a color. I'll pick a lighter shade of blue. Let's try that. Color equals that specific shade of blue. Yeah, not bad. The label is kind of close to the border. We'll be adjusting the margin a little bit later in this topic. To create the label on the y-axis, I'm just going to copy everything within this xLabel function, paste it, change x to y. We'll say the text will be, let's change the text of the label to be students, as in number of students. We should have a similar label on the y-axis. Now we're going to customize the ticks of our graph. Each of these ticks is incrementing by 0.5 each. You can kind of see that here. You can force ticks to only display at these values for the x-axis. Here's how. We'll access PLT, call the x_ticks function, x_ticks, then pass in our list or NumPy array that we're using for the x-axis. So now, we have ticks only at each given year, 2023, 2024, 2025, 2026. Now, to customize the ticks, we will access PLT, call the tick_params function, meaning tick parameters. To select an axis, you'll select the keyword argument of axis. You can select X, you can select Y, or you can select both. We'll select both. We're going to select colors, plural, not singular. I'll select the same color as my labels. Now the ticks should be blue. Alright everybody, so that is how to add various labels to your plots in Matplotlib. Hey everybody, I have a super quick video today on how to create grid lines using the grid function using Matplotlib. The grid function creates grid lines. They help make plots easier to read by adding reference lines. We'll need some sample data to work with. We'll just make something up. On the x-axis, we'll have 1, 2, 3, 4, 5. On the y-axis, we'll have 5, 10, 15, 20, 25. It really doesn't matter. We're more focused on the grid lines today. We'll need a plot, access PLT, call the plot function, pass in x, pass in y. Then access plot, call the show function to show our plot. Here's our sample plot. Now let's say you would like to create some grid lines. For better readability, here's how. We're going to access PLT, call the grid function. Let's see what happens if we don't pass in any arguments. These are the grid lines with no customization. We have grid lines on the x-axis and the y-axis. If you would just like a single axis, you can specify that with the keyword argument. Axis equals, we'll pick the x-axis to begin with. We will only have vertical lines then on the x-axis by setting the axis to x. If we were to set this to y, we would have grid lines on the y-axis. You can change the line width. Line width equals, normally it's 1, but here's 2. The lines are a little bit thicker. Here's 3. Let's set that back to 2. You can change the color. Color equals, then select a color. I'll just pick light gray to keep it simple. The lines are now light gray. You can specify a line style. Normally it's solid. Let's try dashed. Here's dashed. Here's dotted. Here's dash dot. But let's set this back to dashed. Alright everybody, that is a super quick lesson on how to create grid lines using Matplotlib. Alright everybody, for this topic, we're going to create a bar chart. A bar chart compares categories of data by representing each category with a bar. Here's an example that I thought of. You know the food pyramid? We'll create a bar chart to represent daily consumption of categories of foods. Here are the different categories. This will be a Python list. Categories equals, we'll create a Python list. The first element within this list will be grains, such as bread. Then fruit, vegetables, protein, dairy, and sweets. We'll create another Python list of values. For each of these categories, what value should each of them have? Let's pretend that these values are for daily servings. How many in each category did I consume today? We'll make up some numbers. For grains, this will be 4. Fruit, 3. Vegetables, I don't eat very many vegetables, that will be 2. Lots of protein, that's 5. Dairy, 3. And sweets, 1. But feel free to make up your own numbers. Now, although it's not necessary, I'm going to convert these Python lists to be NumPy arrays. Alright, we are ready to make a bar chart. Categories will be on the x-axis, values will be on the y-axis. Rather than using a plot such as plt, called the plot function, we're instead going to use bar to make a bar chart. First, pass in what's going to be used for the x-axis, categories, comma, then the y-axis of values. And then you do have to show your bar chart. plt, call the show function. And let's see what we have. Here we go. A bar chart compares categories of data by representing each category with a bar. Here are the categories that we've stated: grains, fruit, vegetables, protein, dairy, sweets. And here are the values on the left-hand side for each. Let's add a title and 2 labels to our bar chart. plt, called the title function, then pass in a title as a string. We'll say daily consumption. Let's make sure that works. Yes, it does. We'll add a label to the x-axis. plt, x label. We'll say the word food. Yep, it says food. And you can change the size if you want for these labels, but that might be overkill for this lesson. We've already covered that in the previous topic. plt, call the ylabel function. We'll pass in a string that says quantity. And it should say that on the left-hand side. Now let's change the color of our bar chart. When we call the bar function, we can set the color to be a color of your choice. You can pick a color name, you can use hexadecimal values. I'll just say sky blue. And the bar colors should change. Now, if you would like a horizontal bar chart, I'll comment this line of code out, copy it, paste it. You're going to instead call the bar h function for a horizontal bar chart, which looks a little something like this. But honestly, for me, I prefer the vertical bar chart. Alright everybody, so that is how to create a basic bar chart using Matplotlib. Alright everybody, we are now going to create a bar chart using Matplotlib. A bar chart, it's a circular chart divided into slices to show percentages of the total. It's good for visualizing distribution among categories. In this demonstration, we're going to create a fictional college. There will be 4 classes: freshman, sophomore, junior, senior. We'll create a Python list of categories. We'll have freshmen, sophomores, I think I misspelled that, juniors, and seniors. We'll also create a Python list of the number of students in each class. Values equals a Python list. We'll have 300 freshmen in our college, 250 sophomores, 275 juniors, and 225 seniors. If you're familiar with NumPy, you do have the option to convert any numerical Python lists to NumPy arrays. Although for a list of 4 values, it's not really too beneficial. If this were a larger dataset, we would benefit from NumPy arrays more, but it would be a good habit for us to develop. Now, Python list of strings don't really benefit from NumPy arrays. We'll keep that as is. We have the 2 collections that we need, categories and values. To create a pie chart, we will access plt, call the pie function. pass in our values. Let me show you what just passing in values will look like. We will also call the show function, plt.show function. We do have the distributions, but we don't have any labels. Here's how to set the labels. When we call the py function, we will pass in a few keyword arguments. The first will be labels. What are the labels of our pie chart? The labels will be the categories that we have. Labels equals categories. And we should have some categories for each of these pie slices. Freshmen, sophomores, juniors, seniors. You can add some percentages to each of these pie slices. Here's how. That's going to be another keyword argument. The keyword argument is auto PCT. This means auto percentage. We have to set this equal to a formatting instruction. We're going to use %1f. Let's see what we have. All right, we don't need all these digits after the decimal. Let's limit that. After 1, we'll add 0.1 to display one digit after the decimal. 28.6, 23.8, 26.2, 21.4. To add a percent sign after, we'll use double percent signs, because normally using 1% sign is a format specifier. Okay, now there's a percent sign after each of these numbers. Here's how to set the colors for each pie slice. We'll create another list for convenience, which I will name colors. Colors equals, then in order of your categories, place a color within here. You can choose a color name, RGB values, hexadecimal values. We'll just keep it simple and pick some color names. Freshmen will be red. Sophomores will be yellow. Juniors will be blue. Seniors will be green. And then we do have to pass that in as a keyword argument. Set colors equal to our list of colors. And the colors should change. Freshmen are red. Sophomores are yellow. Juniors are blue. Seniors are green. Let's add a title to our pie chart. PLT, called the title function, pass in a title. My college will be named Bro Code College, because I think I'm cool. You can explode one of these pie slices. Explode means to displace it slightly, if you need to highlight a pie slice. We'll explode seniors. For the keyword argument of explode, we'll set this equal to a Python list. We have 4 categories. We'll need 4 values. I'll set each of these to be 0. I need to explode seniors. I'll set this to a value that's not 1. Let's start with 0.1. The greater the number, the further the distance that pie slice will explode. Here's 0.1. Let's change that to 0.2. The distance traveled should be a little bit greater. Here's 0.3. We'll set that to be 0.2. That's pretty good. And 0.1. We can also add a drop shadow. Shadow equals true. And there should be a drop shadow for each pie slice. To rotate your pie chart, you'll set start angle to be some angle. If I were to set this to be 180 for 180 degrees, my pie chart is going to rotate by 180 degrees. I'll just set that to be, let's check out 90. That's pretty good. Alright everybody, so that is how to create a basic pie chart using Matplotlib. Alright everybody, in this video we're going to discuss scatter graphs in Matplotlib. Scatter graphs show the relationship between two variables. They help to identify a correlation, positive, negative, or no correlation. For example, the more hours you study, the higher your test scores tend to be. That's a positive correlation. Scatter graphs help us identify those correlations. In this demonstration, I'll create the following dataset. You can either follow along and type what I'm about to type, or look in the comment section. I'll try and post this dataset. We'll have X, which will be a Python list. These will be hours studied for various students. we'll have 10 values. The first student didn't study at all. They studied 0 hours. Another studied 1 hour. 1, 2, 3, 4, 5, 6, 7, 7, 8. Feel free to make up some numbers too. It really doesn't make a difference. Then y will be the test scores. This will be another Python list. The student that didn't study at all, they got a 55% on their test score. The first value will be 55. Then another got 60, 65, 62, 68, 70, 75, 78, 82, 85, 87. That's good enough for now. To create a scatter graph, we're going to access PLT, call the scatter function, pass in x, then pass in y. X is for the hours studied. Y is for the grades. What grade did they get on their test score? Then in order to show this graph, we have to call the show function, plt.showFunction. Let's see what we have. Here is our scatter graph. You can see that there's a positive correlation between hours studied and the exam scores. Let's add some labels to our scatter graph. For the x label, access plt, call the xLabel function, then pass in a string to serve as the label. Hours studied is good. Let's make sure that that works. Yes, it does. We have a label for hours studied. For the y-axis, call the yLabel function, then pass in a string. We'll say grades. Or grade, singular. Let's make sure that that works. Yes, it does. Here's the grade. Then let's add a title. PLT, call the title function. I'm going to say test scores, just as a general title for our scatter graph. Let's add a little bit of customization. Let's change the color. This will be a keyword argument. Color equals some color. You can pick a color name, you can use RGB values. I'll just say sky blue to keep it simple. And the color should change, which it does. You can also change the alpha. Alpha is related to the transparency. If I set alpha to be 0.5, that's 50%. The transparency is going to change, although it's a little hard to see. If I set alpha to be 0.1, then the transparency is 10% and you can barely see it. I'll keep it at 50%. Let's change the size of our dots on our scatter graph. That would be S for size. Let's check out 100. That's bigger. Here's 200. Yeah, we can keep it at 200. That's a good size. Okay, let's create another data set. The following set of scores will be for one class. We'll add another class of scores. Although it's not necessary, I forgot to make these NumPy arrays. You can if you would like. Let's rename x to be x1, y to be y1. Pass in x1 and y1. We're going to create a whole nother set. Let's copy and paste x1 and y1, rename them as x2 and y2. And let's change some of these values around. For the second set, we'll have 0, 1, 2, 2, 3, 4, 5, 6, 7, 8, 8. Then for the exam scores for the second class, we'll have 50, 58, 65, 70, 72, 78, 83, 88, 92, 95, 97. We're going to call the scatter function again. We'll copy and paste what we had previously, but pass in x2 and y2, the second set of coordinates. Let's change the color to be red. The blue set of dots is for class 1. The red set of dots is for class 2. Based on this graph, we can't tell without a legend. The legend will tell you which class is which. But we'll need some labels. We'll pass those in as keyword arguments. For class 1, we'll set label equal to class A. And then for our second class, this will be class B. Label equals class B. But then we have to show the legend, because it's not visible. Access PLT, call the legend function. Then we should have a legend within our scatter graph. Class A is the blue dots. Class B is the red dots. Alright everybody, so those are scatter graphs. They show relationships between two variables. For example, hours studied and exam grades. The more hours you study, the better grade you tend to get. That's a positive correlation, which we can see from this graph here. And well everybody, those are scatter graphs using Matplotlib. Yo, hey everybody, in this video I'm going to explain histograms in Matplotlib. Histograms are a visual representation of the distribution of quantitative data. In short, we can visualize the distribution of data. Histograms group values into bins. Think of these like intervals. We'll count how many fall in each range, in each bucket or bin. Histograms are great for statistics and probability. In many cases, you'll see a bell curve distribution. Now, in this demonstration, I recommend using NumPy because we'll need a lot of data to work with. With NumPy, we can generate some random numbers. Here's how we can do that. We're going to create some test scores. We're a teacher and we have 100 students that each took a test. We'll create a visual to display the distribution of scores. We'll create a NumPy array of scores. Scores equals NP, access random, then call the normal function for a normal distribution. There's a few keyword arguments here we'll pass in. The first is LOC. LOC equals, LOC is the location of the center, the median of our data. For the center, we'll say that the median is 80%. All of the test scores are going to cluster around this score of 80. Most students will do pretty well. If this were a lower score like 50, that means most of the students failed. That's because the most frequent score is going to be around 50%. We'll set that to be 80. Now we'll need a scale. This is another keyword argument. Scale equals, scale is the standard deviation, the spread. How far away are the scores going to deviate from the center? The higher the number, the greater the deviation. Let's start with 10. And then we need a size. How many numbers do we want to generate? We'll set size equal to 100. We have 100 test scores. Let's test what we have currently. We'll access PLT, call the hist function for a histogram, pass in our NumPy array of scores. Then we do have to call the show function to show our histogram. Access PLT, call the show function. Here's what a histogram looks like. We set the center to be 80. Scores around that number are going to be the most frequent. And we've set the scale to be 10. 10 is the standard deviation. That's a statistics and probability term. How far away will the scores deviate from the center? Now, if I set the scale to be a small number like 1, the scores are going to cluster more closely to 80. The lowest score was 77, the highest score was 82. If I set scale to be a big number like 50, well then the scores really deviate from the center of 80. We have some students that scored below 0 and others above 200. Let's set that back to 10. Just to ensure that no scores go below 0 or above 100, we can use the clip function. We'll reassign our NumPy array of scores. Access NumPy, call the clip function. We have to pass in our NumPy array of scores. For any scores below 0, we'll set them to be 0. We'll clip them. For any scores above 100, we'll clip them down to 100. It's kind of like we're setting the bounds, the minimum and the maximum. All scores below 0 will be set to 0. All scores above 100 will be set to 100. Let's set the scale back to something massive like 50. Yep, there's no scores below 0 and no scores above 100. But we don't need a scale that big. Let's add some customization. You can set the number of bins that you want as another keyword argument. This will be within the hist function for a histogram. I'll set the number of bins to be 10. We should now have 10 bins, or intervals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I were to set this to 20, we would now have 20. But I think 10 is a good number. Let's change the color. That's another keyword argument. Color equals pick a color. I'll just set my histogram to be light green. There we go. To better define the edges, you can set an edge color, because right now it kind of looks like one massive blob. Edge color equals, I'll set it to be black. We should get a nice outline around each interval, or bin. Let's add some labels because, well, I forgot to do that. Let's add a title, plt, called the title function. We'll say exam scores. Let's make sure that that works. Yes, it does. Let's set a label for the x-axis. plt, called the xLabel function. We'll say score. Here we go, score. And for the y-axis, plt, called the yLabel function. Number of students. Number of students is on the y-axis. Alright everybody, so that's a histogram. It's a visual representation of the distribution of quantitative data. We're displaying the distribution of data. And well everybody, those are histograms in Matplotlib. Yo, hey everybody, in this video I'm going to show you how we can create subplots using Matplotlib. There's a couple definitions we'll need to cover, one of which is a figure. A figure is the entire canvas in which we add a plot to. Then we have an ax. An ax is also known as a subplot. It's a single plot within a figure. A figure can contain multiple axes, or subplots. We're going to call a subplots function. It's going to return a tuple that has a few things inside of it. Just to demonstrate, temporarily I'm going to print axis plt, call the subplots function. Within the subplots function, we're going to determine the layout of our figure. How many rows and columns of subplots will be within our figure? For example, we could have a 2x2, 2 rows, 2 columns, or 2x3, 2 rows, 3 columns, or a 3x2. 3 rows, 2 columns. Let's stick with the 2x2 for now. I want to show you what this function returns exactly. It's a little complex, but we'll break it down. The subplots function, it will return a tuple. The tuple has 2 entities, a figure object, which is our canvas, and a 2-dimensional array of axes objects. When we call this function, we're going to unpack this tuple right away. Rather than use print, we're going to assign what's returned to us and unpack it. We'll create a figure object and an axes object. Figure and axes equals, call the subplots function. Figure is our canvas. We won't actually be using it in this topic, but we're provided with it by the subplots function. We'll print this 2-dimensional list right away. Here's how. We'll plot each of these subplots, but we won't add any data quite yet, not until later. If I was to call the show function, we can see all the subplots that we have. Axis plt, call the show function. We have 4 subplots, 2 rows, 2 columns. If this were a 1x2, 1 row, 2 columns, we have 2 subplots. Or a 2x1, which would be 2 rows, 1 column. A 3x3 would be 3 rows, 3 columns. We don't need that many subplots, but I think you get the idea. We'll have a 2x2. 2 rows, 2 columns. We'll fill each of these individual subplots in. Here's how. We'll start with the top left corner. Row 0, column 0. We'll access our 2D list of axes at row 0, column 0, and then plot it, calling the plot function. We will need some data. We'll keep it simple. We'll say x equals a NumPy array with a list that contains 1, 2, 3, 4, 5. We'll plot x, but to keep it simple, we'll just say y will be x times 2. Let's take a look. We've selected the subplot at row 0, column 0, so only this one is filled in with our data. Let's customize it. Let's set the color to be red with a keyword argument. The color is now red. And let's add a title. We need to select that specific subplot using a set of indices. Axes at row 0, column 0. Call the set title function, then pass it a title. We'll say x times 2 for the title. And there's the title for this specific subplot. Now we'll plot the top right subplot. We need to select that specific one. That would be row 0, column 1. We'll call the plot function, pass in x. We'll say x to the power of 2 for the y-axis. Select a color. I'll select blue. Then set the title. Axes at row 0, column 1. We will set the title to be x to the power of 2. The top right subplot should now be plotted. Alright, let's select the bottom left corner. That will have different indices. Axes at row 1, column 0. We'll call the plot function, pass in x. For y, we'll say x to the power of 3. We'll set the color to be green. Then set a title. Axes at indices of 1, 0. Call the set title function. This will be x to the power of 3. Oops, looks like I misspelled color. There we go. Some of these subplots are overlapping. You can add a tight layout so everything fits. Access PLT, call the tight layout function, and now they should all fit in place, which they do. Let's finish this bottom right corner. I'll just copy and paste the last 2 lines. That would be axes at row 1, column 1. This will be x to the power of 4. The color will be purple. Axes at row 1, column 1. We'll set the title to be x to the power of 4. There we go. We have now filled in the bottom right corner. Now, if this were a 3x3, well, then only these 4 subplots are still filled in, but we really don't need that many. Now, you don't necessarily need to use plots. You could use different graphs instead, such as a bar chart, or whatever else you would like. Alright, everybody, and that is how to create subplots using Matplotlib. Yo, hey everybody, in this video we're going to integrate both Pandas and Matplotlib. In my Panda series, we've been working with the CSV file that contains the stats for the original 150 Pokemon. We'll be reusing that in this series. Or if there's another set of data that you would like to work with, feel free to use that too. I'll post this in the comments section on YouTube, and you can just copy and paste it if you would like. Just be sure to put it in a CSV file. To work with Pandas, we'll need to import it. Import Pandas. We'll give it a nickname as PD for short. When we read a CSV file, we're going to assign it to be a data frame, which we will name df. df equals access pandas as pd, call the read CSV function, and then pass in the name of that file, or a file path. The name of my file is data.csv, and it's right next to my main Python file. I don't need a file path beforehand. Let's be sure that it works. I'm going to print my data frame. Here are all the stats of the original 150 Pokemon. It's a truncated view though, but that's good enough. We'll create a bar chart that shows the quantity of the primary types. For example, there's grass types, there's fire types, dragon types, so on and so forth. We'll be selecting only a single column, a single series, type 1. There is a secondary type of type 2, but we won't be concerned with that in this video. To select a single column, we'll be using the subscript operator, which is a set of straight brackets, then select the column. We will select type 1. That is the primary type. We'll be returned with a single series, a single column. There is a built-in function of series. It's called value_counts. And this is a function. This function will return the number in each category. So if I were to run this, we would have a total of 28 water types, 22 normal types, 14 poison types, 12 fire types, and a whole bunch more. We'll plot the quantity of each type. The index we'll put on the y-axis with a horizontal bar chart, and the values we'll place on the x-axis. Now for convenience, I'm going to assign our value counts. We'll say type_count equals this series. Type count will be a series. It will hold the amount of each type. Now, to create a bar chart, we'll access PLT, call the bar function. We'll create a horizontal bar chart in just a moment. For the x-axis, we'll access our series of type count, but I would like just the index. We don't need the entire series. And for the y-axis, we'll need the values. Take our series of type count, access the values. Let's see what we have currently. We'll do a test run. Be sure to show your plot because I forgot to do that. There we go. Here's our bar chart, but we have a little bit of work to do. All of these index names are grouped together. Let's place them on the x-axis with a horizontal bar chart. We'll use a horizontal bar chart with bar H. That's a lot better. Now, they're in ascending order. I would like the values with the most on the top rather than the bottom. Well, when we create our type count series, we can pass in a keyword argument. Ascending equals true. And they should now be in reverse order. You can change the colors if you would like. Pass in a keyword argument of color, then pick a color. I'll use a hex color picker. I'll pick something blue. That's pretty decent. I'll copy the hex value and then paste it within that color keyword argument. Not bad. I'll also add an edge color of black. Edge color equals black. Let's add a title and some labels. PLT, call the title function. This title will be number of Pokemon by primary type. Let's make sure that it works. Yes, it does. For the x-axis, we'll say count. PLT, call the xLabel function. Pass in the word of count. There we are. Then for the y-axis, axis PLT, call the yLabel function. Pass in a word of type. Just to make sure everything fits, we're going to call the tight_layout function so that everything fits. PLT, call the layout function. And now everything should fit within our figure. Alright everybody, so that served as a final project for us. That's how to use both Pandas and Matplotlib together.